My name is Malcom Gillett. I'm a senior analog layout engineer at Moortec Semiconductors in the UK. I'd like to share with you today some of our recent experience of working in deep sub-micron technologies. Deep sub-micron processes come with a number of specific challenges. We see an exponential increase in the number of design rule constraints and their complexities. Minimum and maximum density check requires uniformity across the die. Layout dependent effects on full custom analog design impacts specifically on productivity and consequently are increasingly important. With 16 and 7 nanometer processes, then colouring also becomes an issue. So after careful consideration of these challenges, we've found that a tile-based methodology using Cadence software offers us the most practical solution. Firstly, we create a base tile cell, adding power supplies, VSS, VDD power supplies for N and P channel structures as well as substrate contacts. We also add PI boundary, N-well and N and P implants, which can then be switched off in the P cells when we add the devices later. That reduces the visual load. And metal routing. So we must consider the amount of metal 2 and metal 3 required. To satisfy electromigration constraints and reduce the IR drop, it may be necessary to use the stranding technique. Orientation of metal layers must be strictly maintained in accordance with the PDK requirements. If odd numbers of routing channel are used within the tile, they can be coloured at the base tile level. This means that the tile can then be placed mirrored and or flipped without compromising the integrity of the colouring pattern. So to the base tile we insert dummy structures which help mitigate STI effects, while filler tiles can be used to keep match devices N or P channel away from active N-well edges. Following this, we then instantiate the transistor devices. We use as few device sizes as possible, which are combined in series or parallel to create a full range of transistors to complement the analog cell library. With a complete analog cell library and each tile DRC and DFM cleaned by construction, it's possible to floor plan very accurately. Grid placement of matched and interdigitated devices, current mirrors and differential pairs can be arranged about an axis of symmetry. In conclusion, the tile-based approach is both practical and meets our criteria for addressing the various challenges. As there is no variation in the library file hierarchy, the layout remains compliant with Cadence Virtuoso XL. The design phase is greatly simplified, which in turn improves layout efficiency. Quality and reliability are improved. Extract and simulation, which takes fill into account at an early stage, provide improved correlation and yield. Reduces the amount of resource required during the layout phase of the design and reduces the number of layers the designer must interact with. And the DRC and DFM usage are maximised. Thank you very much.